All right, folks, I hope everybody's doing well. We are going to get started with module number 12, which is going to be talking about the Falling Sands project that's going to be coming up. Your next assignment, I actually decided to have you do the binary tree implementation because I think that'll be very useful for folks. So you'll see assignment 6 in your repositories very soon here. So let's go ahead and dive into the slides and continue learning some C++. And just a little follow-up from the survey from last week. I think most everyone's filled it in, so it feels like about most of the people, we've got almost a bell curve here. We're looking at the course, and it's moving about right. And again, lots of people are using CPP reference, which is great. And Cherno is still only at 4 votes here, so maybe I'll look for some other videos that might be helpful, or just keep doing some more live examples so you can see, again, directly from me. Again, my examples are going to be a little bit more focused on the homework and maybe a little bit more helpful in that way, but it is useful sometimes to get another perspective or just see things a second time or explain a second time. And you'll pick up new tricks that way, or just kind of make your knowledge a little bit more concrete. So I do recommend watching some of those videos, even if you watch them at 2x speed, just to reinforce and review some concepts along the way. All right, so with that said, let's go ahead and move forward. So last time we talked about linked data structures. So of course that linked data structure that we looked at was the tree. And we looked at the specific instance, which was the binary tree, and how to perform some of the common operations, like inserting into the tree, updating the tree, or rather printing or checking if something exists. So I thought that was a pretty useful example, and you've got a video and I suppose some starter code in the repository for that to study. And that's what I actually think is going to push you a little bit further in this class as far as just understanding some more C++ and pointers. Binary tree is a really good one to implement. Most C++ interviews that I've had for entry-level positions, I can recall a few that were of the nature of sum up all the items on the left side of the tree, or sum up all the items, that are even, or these kind of problems. So I'm going to have you folks do the binary tree implementation and choose one of these sort of real-world interview questions that I had to, again, get you a little bit more practice on just building data structures and getting more comfortable with working with pointers, okay? All right, so with that said, let's go ahead and continue on. So again, the logistics, are going to be to have you finish the implementation of A6, which we did in the previous module, so you can refer to that for at least some working starter code if that's what you want to start with. Otherwise, you have a little bit of freedom to implement things as you want, if you want to build it from scratch. I also want to give us a little bit of practice on building tests for our code as well. So one of the challenges in this course is we're going to be doing a lot of stuff with pixels. And that's great for the visual output, so we can usually see if something's working right. But we want a little bit of practice, and for folks who have gone through the Fundies sequence, you've probably gotten used to writing and passing tests. So we want to look a little bit about just some basic unit tests in C++, so we can make sure if we add some element to the binary tree that it exists. And that'll be a good way that you can have some confidence that your code is working in C++. We've been doing a lot with the bug debugger, which is really great, and that's one way to certainly have confidence that our code is working and it's meeting our expectations. But at some point, at scale, meaning as your binary tree gets really, really large, it's nice to have some test cases for that, okay? So we'll get a little bit of practice there as well. Okay, and then as I mentioned, we're going to talk about A7 today, which is the Falling Sands game, and that should be released most likely Monday, late Monday or early Tuesday, because it's a holiday weekend, but that will be the next assignment released for you. So I want to talk about it a little bit just in case folks feel like they're able to catch up or want to get a little bit of a head start on the long weekend. But just to have you folks have that option. So with that said, let's go ahead and dive into it. And let's just talk a little bit about what you're going to be building. And I want to just take you through the process of building from scratch a new program, because this is what you're going to be doing for the sand game. Okay, so the first thing to know is, just to have a play at what we're building here, just to get an idea. And these sort of sand games go back all the way to about 2005 was the earliest that I could find about the wiki on sand games. But just to give you an idea of what this is, it's sort of a way to paint or create art here. So you can create shapes with your cursor and select different materials here. So I'll zoom into this a little bit more just so folks can see. And depending on the material you have, so maybe you have more sand here, then the particles act in different ways. So blue is water, this is like a salt, and I think this is a like a soil or something here. So I think if I put some plants here on the soil, let's see if it does anything. Oh, maybe not anything interesting. Fire is kind of an obvious one here. And so you can have a lot of fun with this, sort of just building some walls here and seeing what the different materials do. So let's put some oil here and then a little bit of fire here, and you can kind of see things ignite here. So it's kind of interesting to see how these particles interact here. So it's a really nice way for us to also build a sort of object-oriented system, because you can imagine that each of these different particle types are just objects in our game here. Okay, so there's a lot of different ways you can structure this, and it's kind of fun here. So I'd recommend having a play here, and just so you can kind of understand what it is doing. Now you're going to have some freedom here as far as what materials that you make and so on for your project. So let's talk about that a little bit here. And just a little bit of inspiration where these sort of sand games come from and why they're kind of neat is there's something called cellular automata, which are basically an idea of modeling, what's happening at the molecular level. So for any of us who have taken, biology or these kind of courses, right, very small scale, what this visualization or simulation is doing is each of these black pixels here are able to move in a certain direction. And if they're next to another black pixel, they might duplicate and so on. And they have different rules about how they move. They're very simple rules. If you're next to some other black cell, there's some percent chance that you will replicate and then move in a certain direction. And it kind of creates these interesting phenomena here, just from those very simple rules. Conway's Game of Life is what this is sort of showing here, this sort of simulation here. So scientists even will use these sort of simulations to model, stuff like on population studies and sort of visualize how things work. So this is pretty cool. You can check out, where some of this stuff comes from. This is from Wolfram here, but if you search cellular automata, you'll find some interesting results. So this is sort of the foundation of our sand games. Okay. So the way these games work is by following relatively simple rules. Okay, so we're basically going to be designing a game where you have different particles, a game or a simulation, however you want to think about it, where you have sand, for instance, and its ability is to move down. It can move down to the left and down to the right. Okay, that's really it. That's all that this sort of sand particle can do. If we have water, on the other hand, its ability is to move down or left or right, and that's it. Okay, so it can move down if this space isn't occupied in the world. Otherwise, it'll choose randomly left or right, and that'll sort of give this idea of water flowing around. Okay, and sand, the same rule. If there's nothing occupying below it, we can move down. Otherwise, we choose randomly down to the left and down to the right. Okay, so just with these sort of simple properties here, we can get this sort of interesting behavior, I guess, of these simulations. So let me go ahead and I'll actually show you a very simple solution that I have for the game. And that could be, considered something that you can build for your project. So I'll go ahead and launch my sand game. And you can see I just initially spawn a bunch of particles here and they kind of fall down. And you can left click to create some more sand particles or right click to create some more water. And you can kind of see, depending on where my cursor is, this water is kind of flowing back and forth to give a little bit of ocean here. And then you could create some sand with the other mouse click. And I just sort of have some stone at the very bottom here so that it doesn't, all the particles don't fall through by default. So that's the idea, to build this little game here, and that's what we'll want to start building today. Okay, so we'll get a little example of that. So you have a little bit of freedom in how you do this implementation here, and this is just a quick one that I wrote up here to demonstrate for you folks what you'll be doing for homework. Now, the nice thing about Falling Sands is we're gonna do the walkthrough, but I want to go ahead and just show you some examples before we do that. So let me jump to the helper videos here. And some of you may have seen this project or similar projects previously. There's a really nice talk here. It's about 30 minutes on exploring the tech and design of Noita, which is a game based off this. So this gentleman here is going to talk about how to model the water, what the rules are, and so on. And I also found there was a really nice talk here on YouTube from this gentleman who is recreating this effect, and he talks a little bit more too about the things that we've done. So if I go ahead and click on these, let's go ahead and get past the commercials. Then we can see how they model the particles here. And we don't have to model all these things, but just what the sort of sand algorithm is. And he gives a nice sort of pseudocode of what happens. And let's actually keep that up for a moment, because that'll be handy for us. So again, if the cell below us is empty, we can move down. Otherwise, we move down to the left or down and to the right. And if we can't move anywhere, then we just stay put. Okay, so that gives us this sort of sand behavior here. And you'll notice it's not perfect. The sand flows all the way down left or all the way down right. So, depending on which condition that we are checking first. And there's ways to sort of figure that out. But we just want to get something that's sort of working here. Water also has a similar idea here. Let's see if we can get that water algorithm here. Yeah, the same idea. If these cells are occupied below us, we move left or to the right. Alrighty, so anyway, so these are some nice talks to watch. These will be included in your write-ups, but I think these will also give you a slight advantage if you watch these and capture the ideas before just diving into the code, okay? Okay, so let me back up just a little bit and do a little bit of our walkthrough here. So the idea is just to today create something very simple in SFML, so you can see how I sort of approach starting a new project that you'll be doing, and capture some of the major ideas. How to create the SFML project from scratch, building a sort of 2D grid for our world to keep track of the different cells, creating a sand particle that falls down and has some rules, and then just splitting up our project into separate pieces to manage the different objects that we create. Okay, and I'm just going to sort of build this program iteratively. I'll try to make some mistakes or design decisions and just kind of explain the design for us. Okay, so we'll dive into that for a moment. So again, you're going to have sort of for this Falling Sands, demo or project, you're going to have freedom to perform your own implementation, but the requirements are that you have at least 3 materials that behave differently. So at least modeling sand, water, and some stone, for example, would be 3 good ones to start with. They're pretty well defined. Air, which is the sort of default material, that doesn't count. So you need sand, water, or stone. At least 3 there. You're welcome to implement others if you get inspired. And this can be a really fun sort of portfolio project for you in the future if you want to expand on it in your own way. But these are the minimum requirements. So let's go ahead and start our walkthrough here. So the first thing that I'm going to do is I'm going to open up a terminal here, and I'm going to move into our CPP directory. So this is where we have all the contents here, and you can see that I'm doing this from scratch. So I'll move into the directory 12 here, and this is where I want to create my main file here. And I'll make this just a little bit bigger here, and I'm going to split the window here with Tmux. Okay, so the first thing that we want to do is create an SFML application from scratch. Okay, so how am I going to do this? Well, usually I'll just want to go to the SFML org here, and I like looking at the tutorials and just grabbing this sort of hello world here is fine here. So sort of opening the SFML window. The drawing 2D stuff has a nice example of just how to do the different drawing on sprites and these kind of things. So this is a good starting point to start with here. Okay. For completeness, I'm just going to paste it in, but typing it out is always good to understand the SFML library. So this is going to be our main function here. Okay, so let's just paste it in. And I'm going to add a little reminder to myself, so attribution in the README site, SFML tutorial at, copy that URL here. Okay, just to get in the habit there, since we're borrowing that code. Okay, so let me make this just a little bit wider, I guess, so you can see everything on one screen here. And at this point, let's just get comfortable with compiling here. Okay, so again, anytime I make some change here, let's go ahead and just make sure that it compiles. So we need G++. We're going to use C++17. I'm going to compile everything in debugging mode -G and our main file here. Okay, so I can just try compiling that. And again, you're going to see these undefined references, to SF string. Okay, so that's something in the SFML library, anything that begins with SF. So we need to link in our libraries. So that's -L for linking in. And they have names like SFML-system is one that we need. Oh, that doesn't make it quite happy. We need lsfml-window. Still not happy. And then we need lsfml-graphics. Or graphic, I forget what it is. Let's see what it is. Oh, -L. There we go. All right. And now it's happy. I just happen to have those three memorized. You might say, well, Mike, how did you know that? Well, let's get used to going through the documentation and sort of the getting started. I'm on Linux here. So if you're using the virtual machine, another advantage of using that is you can see or follow directly along and don't have to worry about the install. I've already set up the library for you here. For compiling the application, it gives us a little bit of help here. So it tells us how to compile this in the libraries that we need to link in. Remember, these are the external libraries that have all the implementation of the graphic stuff we want to do, or opening a window, or any SFML system stuff that it needs. Okay, so that's how we create our application. Okay, so now let's just go ahead and run this program. What did it create it as? A.out here, the thing in green here. Let's actually just remove that and give it a name here. So remember when we compile, and let me just put this all on one line so that you can see it. We want to output the actual binary name. So that's -O space and then the program here. Okay, and that gives us the program. Okay, so if I run this, I get a window here. Okay, so that looks pretty good to me. 800 by 600 window. I'm actually going to make it a little bit smaller. And because I have these sort of boundaries here, I like to just maybe define these. We can make them global for now. They're going to be integers that don't change. I'm just going to call it G, our sort of world width, and G, our world height. Okay, and let's initialize these. Let's do like 400 by 400 for our world here. Okay, so we have this here. G world width and G world height. Okay, and we'll go ahead and give this a different name here. Following sands. Okay, made a few changes, so I always like to rerun. I do that frequently, and we can see we have our new window here. Okay, so at this point, I've made a few different changes here. So I'm going to go ahead and add our program to our repository and just say basic SFML application is built. Okay, and let's go ahead and just push those changes. I can see what I have here. And so far, so good. So we push frequently as we make some different updates and hit our sort of benchmarks, okay? So now what are the other things that we want to do? So we've got this idea of creating the SFML grid, or the application, and we'll want to sort of build a grid, okay? So what exactly does that mean here? Well, if we go ahead and, now that we have things working, let's go ahead and sketch a little bit. And this is just another tip for whenever you're building an application from scratch to, try to draw it out and have a little game plan. Having implemented this before, I have a little bit of an idea of what I want to do, and watching those tutorials so I can learn from the other folks. But having a little game plan here can also be very helpful. So this is our window here. We said falling sands or whatever. But really, what I want to do is have some of these particles. Okay, so this is some particle, and it could be sand, for instance. And I want to be able to divide my world into pixels. So this sort of granularity here, okay? This is the granularity that I am working at. So I could draw or fill in all these pixels. You sort of get the idea here. So this is my world. And it consists of these little cells, okay? Or grid of cells here, okay? So the idea is at any given time, I want to know if I have some particle and if it's filled with, say, orange, and let's just say this is specifically a sand particle. I want to be able to keep track of that. So basically what I'm doing, and let me sort of blow this up a little bit here. So let me grab a color here. And so if we look at this little grid here, I'll make it a little bit bigger. This 2x2 section, I have a sand particle in one of the sections. Okay, that's over here. So I want to know if the cell below is empty, then based off of the rules in my system, this particle can move downwards. Okay, or if this cell happens to be occupied here, then I want to know that I can move down to the left or down to the right. Okay, so that's the basic idea. So I have to figure out how do I sort of model this world here. Okay, so I need at a minimum a sort of grid here, okay, for my world. So let's go ahead and think about, now that we have this idea in our code, how we're going to think about it. So we have this idea of, okay, sand or particles, and we could have different types of particles, and this idea of cells here, okay? So let's go ahead and see what it looks like in code if we design this up. Okay, so what I probably want to do here is, we have a couple of strategies here. So this is sort of our dimensions of the world. And we could just dive into this and just sort of say we have our grid here, and I'm putting G in front of it because it's a global here, and make it the sort of G, world width by the world height. Okay, we could do that, and then we would sort of have some functions to organize this. I'm instead going to try to organize this into a class, okay? And you're going to see me just first put it in here to get things compiling, and then we're going to organize it a little bit into a project here. So I'm just going to call this the world. Part of this world is going to be the actual grid here, and now this is a member variable. So let's make this private for now. And the size is going to be actually fixed. But I don't want to determine what that's going to be quite yet, okay? So this is just going to be a pointer to our grid, and it's just going to hold values in it here. Hold values for what particle occupies a particular cell, okay? So that's the idea of what the grid is going to do. Okay, so let's go ahead and make a constructor just so that we can actually create this grid. This stuff needs to be public here. And we'll have our world, and then we want to take in a width and a height. Okay, and that's where our global variables can come in, but we're going to actually want to pass them in here so that we can initialize this grid to some set of values here. Okay, so let's store the dimensions here. And I will go ahead and just write these as width and height here of our world. Okay, and we saw a couple different ways that we can initialize this. So I'll just do the height here and the height. And then we want to initialize our array. Okay, so let's go ahead and do that by just iterating through, or by rather allocating memory and then setting all the values to 0. So m grid equals new int width times height. Okay, and for int I equals I less than width times height, I equals our I plus plus. So we're going to iterate through all the values in our grid and just set them to some value here, like 0. Okay, so again, what is this piece of code doing? Let's make it a little bit smaller and look at our visualization here. So again, that's just looking through each of these pixels. We're creating our grid here, one at a time here, and it's width by height. So that's going to fill all these cells here, and all these in the next row, and all these in the next row. It's just setting their value to 0. Okay, but we can do a little bit better than just 0, because what does 0 mean to us? Well, that sort of means empty, or maybe the value 1 means sand particle or something else. So let me go ahead and jump back into our slideshow, and I want to show you a little C++ trick here. And C++ has available something called an enum. You may have used this in Java, and it's available in other languages, but it's this idea that you can have a set of related data, and it's probably easiest to look at this example at the bottom, but you have a set of related data like colors, and you want to create a new type for that color, and just say red, green, blue. Now these will automatically be assigned values 0, 1, and 2, but you can just refer to them by the actual name here. Okay, so that's really useful for us in the sense that it gives meaning to our variables. So for example, if we have different particles like air, sand, water, stone, we can just refer to them as the particle type : air. So in this enum scope here. We don't have to remember that air is 0, for example, or sand is the value 1 when it occupies a cell here, or water. And maybe we can change around this order, and it doesn't matter because we're just going to be referring to it by name here. So it's a lot cleaner way to refer to things in our code. So I'm going to go ahead and create an enum here, and I'm just going to name it the same. Usually we put them in all capital letters. You'll see that's commonly done. So particle type, and then let's do air, sand, water, stone. And if you add other things like fire or lava or whatever, this is where you can add them. Okay, so let's just go ahead and add those. And then now my grid is not going to refer to integers, but rather the particle type and air. So let's see if this that's what we want here. I rewind, recompile, and it says, oops, use of enum without previous declaration. And I actually don't need to assign this, so that was my mistake here. I'll get rid of that, because we're just initializing it. And then we are still going to have this problem again because this is of a particle type, so we can't convert it back and forth between an integer. So when I'm creating this grid of integers, it's just going to be a grid of particle type things, so whatever those are. So that's what it can hold here. So now we've got to fix all the other things as well. So, so when we initialize this, this is a new array of particle types. Okay. Oops. Recompile. And one more. The fix here is going to be to do I of, and then we can assign it to this particle type here. Okay, So that's what's going on. If we wanted to, just a little thing about enums, we can very explicitly assign these. So if for some reason we wanted to do something like this, we can perform the enumeration there. And that'll give it specific values if these values have meanings. Otherwise, it is just automatically going to assign these in order to the unique values. Okay, so I'm just going to get rid of this because we don't have any need for that quite yet here. Okay, so again, I'll just recompile and reset us here. So we have our world now and all of our particles here that we want to work with. And we've initialized everything to air here. Okay, so let's go ahead and create our world here. So we're creating our window, create our world for the simulation. This is going to be the world. I'm just going to call it W, and we need our world width and the world height. Okay, and there we go. Okay, so it looks like it is working, but it's not really doing anything for us here. So we need to actually create some particles now and create this simulation. Okay, so let me go ahead and I'm just going to tidy this up just a little bit for formatting, and then let's actually take care of this portion here for the actual drawing. But before I get too far ahead of myself and start doing things, let's go ahead and finish off just a small part of this class. Right, we need our destructor here, where we need to delete our grid. So as I create and allocate memory for things, I try to remember to also put them in the destructor here. And then the other thing that I want to do is to go ahead and organize this just a little bit into its own file just as we go forward. So I want to take all of our world part here, and move it to a separate file. So I'm going to create a new file here, and let's just call it world.hpp and paste it in here. We need our header guards, if not defined, world.hpp, and define the world. Okay, and then I'll go to the bottom and put the end if here. Okay, so I have everything there. I do need our particle types. These have to live somewhere here. So I should also put this in another file here. And I'm just going to call this one particle. Particle.hpp. Okay, so I'll split again, paste it in here, do the same thing. If not defined, particle, HPP, define particle. Okay, now if I go ahead and compile this, we're going to see a bunch of errors, right? We're going to see that world was not declared in this scope. So we go back into our program here and include world, HPP. This is in our main CPP program. And we need to, from our world HPP program, since we're using that enumeration, we need to include the particle.hpp. Okay, so let's go ahead and build this, and looks like it's working here. Okay, so now we can further go and split our world program into its interface and implementation. Okay, just because so far I'm happy with this design, and it'll clean things up just a little bit here. So let me go ahead and close this. I'll close our main just so we can see everything, or as much as possible, that's going on here. I'll create the world.cpp. Okay, and that's where I'll implement or add the implementation here. So these things are each part of the world space. So I'm just doing a little bit of refactoring to get things looking nice here, of course. And let me make this a little bit bigger just so you can see everything on one screen here. There we go. And this is part of the world. Okay. And then again, we can see that this is our interface here. So we just need the names. And that's it. And I'd like to add a little bit of documentation here. Constructor and destructor. Okay, so now when I compile this, well, need to fix one other thing here too. I do need to include the world.hpp in this file so that our implementation knows about our interface. Okay. So let me go ahead and I'll keep this for now, and I'll get rid of our world here. Okay, and let's go ahead and recompile here. Okay, now remember, if I'm recompiling this, I am going to get some issues here, because it's going to say, okay, undefined reference to this stuff. Oops, that's because I did delete these guys. So even if I do compile it, though, now I get undefined reference to world, because I need to, we know about it, but we just don't know how it does the work. So I need to include the world CPP file here. Okay, and now we are okay. So this is the full line to compile as of now. Okay, and if I run our program, it creates a world, but it's not doing anything yet. Okay, so at this point, let's pause for a moment. So we've created our world. We've learned a little bit about enums here. So let me go ahead and just see where we're at. So we've created our application. We have a grid. Now let's, and we've broken our project into smaller pieces, so we'll sort of manage that. But now let's go ahead and create our sand particle and figure out how we'll do that. And once we have that, then, you know, the rules and stuff for building water and sand and so on become a little bit easier. Okay, so just a little bit on the design of the particles. And I think there's really two sort of schools of thinking, or two ways that we could implement these sand particles. So we could either have a class for particular particles, and that would control their behavior and then keep track of all of the particles in our world. That's something that we could do. Or we could sort of try to use the grid and sort of manipulate it and just draw particles based off of what they are in the 2D grid. I think either is fine. I'm going to show creating a separate particle class. So let me go to our drawing here. And what I'm going to add is, you know, so these are going to be separate classes, okay, for handling each type of particle. I think this will give you more flexibility if you want to take this project further. But this will be the sort of strategy. So we'll have a water particle class, a sand particle class, and maybe just a interface for all of our particles, okay? So that'll be the idea. And then I'll add each of these to our world here, and they'll be, you know, filled in whatever their type is. And then in our world, every frame will just update all of our particles and move them and update our grid. Okay, so that's the design. That's my design idea going into this. Let's see if it works. And again, there might be two ways to approach any problem, but regardless, we want to go into, when designing software, having a little bit of a plan here. So what I'm going to do is I'm going to let me split this here. So I'll do another split here, and we need our world. And our world is going to need to hold not only the grid, but a bunch of the particles. So I'm going to use a vector to hold all of our particles. So let's do a C++ library, our standard libraries here for the vector. And that's going to hold particles again. Okay, so standard vector, that's going to hold a particle. And I'll just call this m_particles. Okay. So what do I need to do? Well, I probably need to undo those changes. I just deleted everything. Okay, let me add that. Okay, so let me, I'm making some refactorings, make sure I compiled everything. It says, well, particle doesn't exist. Okay, so we have to create that. Okay, so let's go ahead and create our particle class. Now we do have the particle HPP, but let's go ahead and open up the particle CPP file, which will include our particle header. Okay, and for now, all this one has is an enumeration, but I'm going to go ahead and add a class, and let's just add a particle for now, and we'll sort of work with this. So we'll need a constructor. the particle, and a destructor for now. Particle. And we might need some other information. I'm anticipating that we might want to be able to get the position, or perhaps set the position of a particle. Okay. SFML has a really handy SF vector as a return type, which will return an X and a Y in a struct. Okay, so this is basically just a struct, if I was going to create it here, with a X and a Y position. Okay, but we don't have to define that. We could if we wanted to, but for now we just have built into SFML this library here. And I believe if I look into our main CPP, I'll just go ahead and include this graphics here. I believe it exists there. Okay, and actually, since I don't know, let me show you how I'll look up here. In SFML library, let's see. So if I go to the documentation, I can look at the different classes, and I think there is one called vector, and there's vector2. Okay. Oh, let me be even more precise. I'll just include vector2 HPP, and that'll give me the SF::vector2, and then the type that we specify, I believe we can just take in an integer. Okay. Let's see here. So we have some usages of it. Or we can do 2f for floats. I believe 2i is defined here. Vector 2i. Yes. Okay, so this vector 2i is the same thing of creating a vector of integers. All right, so let's go ahead and do that. So I'll go ahead in here, and we're being precise. I just need to include vector 2. Okay. Let's go ahead and see if it's happy with that. Mostly happy. Let's see, what was I missing here? SF vector 2 in the vector 2 HPP. I believe this is already included in graphics, so maybe I was right. Maybe that was okay. Let's see. Yes, okay, it was happy. Now I just have to finish this here. So get position, and that'll retrieve the position with an X and a Y vector here. And maybe we want to set the position, okay, of our particle. So I'll call this set position, and that's going to take in, maybe let's just make this as simple as an X and a Y coordinate. And within our particle, that means we should also have a vector 2i where we store the position, okay, the X and the Y position of this particle. So let's see, so working with the particle. And we probably also want to draw the particle here. Okay, so I'm going to call this draw, or render might be an appropriate name. Either is fine. So let's just go ahead and call it draw. Okay, so now this is what I'm going to implement in our particle CPP here. So let me go ahead and paste this in here. Do the appropriate class scope here with the : because that's where these functions are coming from. And so that's our return type. This will be a particle and particle. And our set position is not going to return anything, so that's just going to be void for the type here. And let's go ahead and just put some brackets here, or curly braces, excuse me. And for draw as well, we will have our particle. Okay. If I try to compile this, it says, okay, in function, undefined reference to our destructor here. Okay, let's see what was missing here. Let me make sure I save this, try to rebuild. And let's see what could be going on. kind of a cryptic error this time in function. So destroy, something where it's destroying a set of particles, and it's got a particle pointer that's undefined reference to particle. Well, let's make sure that I spelled everything right here. I've got the reference here, and this is public, so it is available. So this is something that I should be implementing. So that looks okay. And we have our header guards here, so that also looks okay. I'll make this a little bit smaller just so we can see everything on one screen here. Let's go ahead and see, now where are we using this? We're using this the world HPP, where we're going to have our particle type, and we are including particle here, so that looks okay to me so far. So just undefined reference to particle with the destructor here. So let me just open up our implementation again, particle CPP, make sure that this looks good here. Just keep saving it, and let's clear this. Now, this error is a little bit sneaky. Since we're not doing anything with our destructor, I'm just going to comment it out, and C++ will complain about it if you just have an empty destructor here. So that was the issue there. So we'll implement it later if we allocate any memory here in our particle. Okay, so we want to actually draw this thing. And let me make this a little bit smaller just so that we can see everything else, because we're going to want to view our world here. These are going to be related, so I'll have the CPP here and the HPP file here as well. So let's go ahead and have our world interface here. And let's make these a little bit bigger here. The compilation stuff is not really changing. I'll add the particle.cpp here. I think that'll actually fix the destructor error here. If I, now that I've cleared it, there we go. So now there's an implementation, even though it's empty and not really doing anything, it shouldn't be complaining here. Now it is complaining about at line 11 here. This is not returning something yet, so we'll want to just create a vector for our position, or just return the M position here. Our member variable here is what we are returning. Okay, so that should take care of all of our errors and warnings at this point. So I'm going to go ahead and do a git add at this point. So if I do git status, git add, let's add the particle files, the world files, and hit enter, git status. Let's add our main. And that's all I need to add, all of our CPP and HPP files. These swap ones are just temporary files in my editor, and we don't need to add the binary. So I'm going to push here, or rather commit, so setting up our particle. The reason I'm doing more pushes and showing you folks is so that if you look in the actual repository, and let's do that now, it can be useful. So if I look in the code samples here, into number 12. If I look at one of these files, for instance, or just the history, then you can click on each of these snapshots to see what I'm adding as I'm adding things. Okay, so that's why I'm doing this one in stages. Also to just show you some of the good habits of building things on GitHub and how you can use the tool. Okay, anyway, so what we want to do is perhaps add some particles into our world here, okay? So what I'm going to do is I'm going to write a function here in the world to add a new particle, okay? And I'm just going to call this add particle, okay? And it'll take in some sort of particle type, P, and that'll be enough for us in the world. Okay, so let's define in our world that we want to add a particle. It's particle P. And what this is going to do is whatever our particle is, just add it to this vector here. Okay, So what do we want to do when we add a particle? We probably also want its position that we're adding it here. So let's go ahead and add it to our vector here. So how do we do that? Well, we need to, when we create a particle, then it needs to, we'll set the position here. So let's go ahead and create a particle, or we have our particle. And this is making a copy of it, okay? So we have to be careful. So how do we want to actually pass in these particles that we have here? That's something that we need to think about for a moment. So one thing we can do is we can make copies of these particles and pass them in. And for now, we have a pretty trivial particle with just a position here. But we might have other information too, like the particle type that we want to keep track of. So what kind of particles are we adding? So that makes me think, okay, now we need our particles to have a type here, right, as they're defined here. Okay, so we need the particle type here, which I'll call particle type, M particle type. Okay, so that's something that we might want to write a set function for. So particle set particle type. And it needs to take in one of the enum types here. And I'm just going to call it type. So M underscore particle type here equals whatever the type is that we set for it. Okay. And let's add that here as part of our interface. Okay, so just thinking about what are the things that I need to do to add a particle into our world. Okay, so let me go ahead and make sure that this still compiles, see if I made any mistakes. Oh, a bunch of mistakes. Okay, so the set particle type, well, it didn't return anything. It was just a setting function, so it's going to complain about that. And then just some small things here. In our add particle function here, let's see, did we match our type here, X and Y? Okay, so we just want to think a little bit about what this interface is going to be. Am I going to just create a particle, somewhere else, perhaps in my main loop when I mouse click, and then it will just we'll set that properties there. That'll be something for you to think a little bit about the design. Let's just make it as simple as possible right now, and I'm just going to have some copies made. It's going to be a little bit expensive, so may have to implement copy constructor. Okay, so I'm going to just leave it at that for now. So for now, our adding particle is going to be relatively trivial. So we're going to have M particles and push back whatever the particle is. Okay, and when we push back the particle, or when we add it to our world, what else are we going to need to do? Well, we still need to take care of our figuring out which particles are occupying what cells, and then how do we update them. Okay, so let's go ahead and sort of set that up. So we need our world, the update function here. So let's see, updating our world. Okay. So we need return type and update function. Okay. And this function's job is going to be to iterate through all particles, figure out what type they are. So iterate through all the particles, update our grid structure, figure out what type they are and how they move. Okay, so this will do some of the heavy lifting for us. Okay, so let's go ahead and figure that out too. Okay, so I'm jumping around a little bit here, but we'll see this sort of all come together. And this is just how these projects kind of tend to go with, when they're organically growing. The more of a plan you have, the less jumping around you do. But if it's your first time or doing sort of an ad hoc implementation, then this is what you get here. So let's finish off some of these things for setting our position. This is a vector here. We can set our particle's position, y equals y. All right. And then if we want to actually draw our particle, well, we might have something here like if, or rather, since this is a enum and we know what the particle type is going to be, we can actually just switch on it. Okay. I will leave that for folks here to do. I'll just leave it as a to-do note. Implement as a switch for folks to learn about. But I'm just going to say for now, if the particle type, so if M particle type equals particle type for sand, then we'll draw it in a certain way. Okay. And let me make sure this is tabbed over. And I'll do sort of the same thing, right? So there's going to be a better way for you to do this with the switch. I'm going to leave that as your exercise here. And error. That's all we have for now. Okay. Okay. And how do we actually draw things? So we've got to go back into SFML. I'm going to go back into the tutorials just to show you where I'm learning this from, drawing stuff. Okay, and we're going to draw these as little rectangles, which would be fine. So let's figure out how do we draw a little 2D sprite. Well, we need some sort of shape here. This might actually be a little bit of overload here. Let's see here. Let's just do a basic shape because it just needs to have a color. It doesn't need to have a texture here. So here's how we create a circle and then fill it in. And that's really all that we need to do here, okay, for the drawing of our shapes here. So this is it. We'll create the shape, set the fill color, and then we call draw on it. Okay, so we're almost done with this. So we need to create our shape here. Create our shape. And let's just do a rectangle shape for our particles. And, well, what's the dimensions of this? This is where we can specify things as a float here. And that's the constructor for shape. How did I know that? Well, if you go into the documentation here, let's go to Learn, API, the classes. And if I look at shape, there's circle shape. We'll get down to rectangle shape. And we look at its constructor here. It says it needs a vector 2f and gives us an example here of how it's created. By default, if you don't specify anything, it'll just create it as a 0 by 0 rectangle, which you can't see. And then you can set the size later if you prefer. But that's just what's going on and where I'm learning this stuff from. Okay, so we've got the shape here, and now we want to set the fill color here. So if it is a air, then we'll set the fill color to black, I guess. Something like this. If it's sand, then we'll do like an orange or a brown. And let's just do something kind of easy, or for now, let's just make it white here. I know that's one of the colors that's defined. Okay, and then we actually want to draw this thing. So how do we draw? Well, we need to draw onto some sort of window. Draw our shape here. So whenever we draw our particles, we're actually going to need a reference to the render window here. Okay, and I'm just going to name this window ref, and I'll slow down in a second and just show you where I'm getting this from. Part of it's from memory, but let me open this up from our main. And this is our render window which we're drawing onto. So that's what we're going to pass in by reference. It already exists. So when we do our drawing, we'll know where to find it here. And we just want to pass it by reference because this is something that we want to avoid doing a copy of, because we're going to do lots of drawing of our particles. So we'll just pass things in by reference to make it sort of easier on us. Okay. So somewhere we're going to need to hang on to this world reference here when we're doing our drawing. Okay. So actually, when we construct our world, we might want to just grab that world reference. So why don't we just do that? So we'll modify our constructor again and just pass in the window for which the world we are rendering on is. Okay. So we need to update our constructors here. And this is a SF render window. Okay, and I'll just call it W. And let's call it SF render window. M, and it's the reference to it. So I'll put ref at the end so we know what we're storing here. Okay, and we're passing that by reference here. So let's update our constructor at line 3. SF render window and W. Yeah. Okay. And then we want to set it appropriately. Our M window ref equals well, W, whatever it is. So now we've got we're storing that reference to our window here. Okay, so now our world, we can just when we're drawing our particles, so when we're doing our update, for instance, we can just call for each of our particles, we'll just pass in W here when we draw them, and it'll draw them in the place. Okay, so let me go ahead and save here, and we're almost getting to the finale here. Just want to make sure it compiles, so I'm building you something that works. So there'll be a few error messages here. So at line 20, I always start from the top. I added a capital S here. So let's get rid of that here. Line 20 in my world.hpp, which is down here. So SF, maybe I was thinking of San Francisco there. And just one at a time. Oh, a bunch of other errors here. Okay, so what happened here? Maybe our particle here. So let's just scroll up to the top and see what happens. Usually what happens is we're just, you know, made one small mistake somewhere. So here was the last time I compiled, about here. It says error use of deleted function operator equals here. Okay, so it doesn't like assigning this to W here. And that's at line 19 in our world here. So it doesn't like this here, I guess. M window ref equals W. And that's probably because our types actually aren't matching here. So we're storing a reference here. So let's see if that makes it a little bit happier. Okay, so still some complaints. Oh, I noticed a few on our particle here as well. I just want to clean this up just a little bit on our draw particle here. Just taking in the window reference. Oh, in the HPP file here. So HPP. Our draw is not matching, so that's also causing a bunch of these errors here. So no need to panic, just take these one at a time. And we see, okay, that fixed a few things here. So adding the, well, let's go ahead and continue from the top. That's usually how I like to take care of these things. And I think we might be missing a class here. That might be also why it's complaining, but let's see. And one way to do this is to just hit clear or type clear a couple of times if we're having hard time finding our starting position here, as I am here with all these little errors here. Okay. So there's actually some other ways to handle this, because it's complaining about, it says uninitialized reference member in class, and it's giving this whole spiel here saying, you know, it doesn't like how this is uninitialized here. So what we could do is just make this a pointer. So this could be a use of having a pointer and just point to the address of whatever this thing is that we're passing in. That's the other way that we can deal with this. So let's go ahead and I'll just change the design just a little bit since we're storing this, and I'm going to rename it to window pointer. And the window is going to be something that's long living, so this is okay to do this. Let me rename this pointer, and this is just going to point to whatever the address is here. So let's go ahead and go into our main, and we'll just pass in the address of this window here. See, this is going to live on the stack for the duration of our program here in main. So that's an okay design. I'm happy enough with that since I know it's going to be long-lived. And now I can start tackling some of these other issues here. So there's no matching function call. Well, that's probably just because I forgot to update the header and save the file. Pointer. And okay, less errors, that's looking even better. Error note declaration matches world add particle. Okay, so let's go ahead and see if we refactored this out, I guess, to get rid of the X and the Y positions. Delete 4 words, delete 2 words. Okay, there we go. And there we go, we have something here. So let's go ahead and run it and make sure it doesn't just crash on us. And here's our Falling Sands program, almost. Okay, so again, let's go ahead and fix all the bugs and work on this update. So we've got a way to push in particles. When we create our particles, we'll need to set the particle type and the position and then move them based off of the rule here. Okay, so let's just go ahead and work on the update here and how we're going to do this. So for I equals 0, while I is less than, well, however many particles we have, our size, I plus plus, what do we want to do? Well, we want to update our grid structure. So that's what this first loop's going to do. Update grid structure. Okay. So remember, the grid's going to be sort of how we define our movement. So if I look down in our file, remember we have our mgrid type here. So for each of our particles, I need to be able to get the particle type and set that in our grid. Okay, so whatever the particle is at I, since we're looping through all of them, we want to update our grid, okay, at the ith position, okay, or whatever this position is here. Okay, so let's just go ahead and get the position here. So we need an SF vector 2i equals m particles dot get position. Okay, and then our grid is going to be at well, whatever this position is. The position dot y. So this is going to be our row times, well, whatever our grid width is plus position dot x is going to be equal to whatever this particle type is. So m particles I dot get particle type. Okay, we don't have a get particle type, so we're going to implement it because we said, hey, looks like we're going to need that. So we'll just write a little get particle type function, and it'll return the particle type here. Okay, and it's just a simple one-liner here. So you notice a lot of these functions are actually just sort of getting and setting types here. So that's sort of half the battle. It looks like we're adding a lot of functionality, but when we look at the interface here, it's actually not doing too much. Most of the functions are just getting or setting some value here. Okay, so particle type here, get particle type. Okay, so let me just put that in here. And I like to keep them in order that I have in the interface that I have declared them here. It just makes it a little bit easier to follow along. Okay, so let me compile this. Let's see if we've made any errors here. And so far, so good. So we'll keep working on our world here. And now that we've updated our grid structure, so we can kind of keep track of things, let's go ahead and move our particles. Okay. And then finally, I'm going to implement this as a totally separate function. We'll want to finally draw our particles. Okay. And that'll be just a little bit cleaner here. So let me do draw the particles. Okay, and this is just going to be a simple draw call. Oops, for our implementation. So I can actually implement the draw relatively trivially because it's just going to iterate through all the particles and then just call the draw function on them. So let's go ahead and look at what draw is, and draw just takes the reference to that window here. Okay, and actually, let me think about this will be the pointer to that window now, so I might have to update that as well. Particles I dot draw, and the window that we want to draw them on, which is our M window pointer. So let's update our particles to just take in the pointer to that as reference. Okay, so this is a pointer, so update that there, and our window pointer. Okay, so let's save that, and that one's relatively trivial here, so when we're drawing here. Okay, so let's go ahead and do a few things. So I think our particle is pretty much done here. We have the sort of setting of the type and these kind of things. So I want to work in the main function to just, maybe create some particles here wherever we are working. So to do our actual drawing, what we're going to do is take our world, W, update it, and then do the draw. Okay. So that'll sort of update our grid and then finally do the particle simulation. So I'll do that. Make sure that everything's compiling. So we're calling all the legal functions. And let's actually just run it. Let's see what happens if it seg faults or crashes. So nothing so far. But we do need to actually create a particle here. So let's do that on a mouse click. And again, how would I figure out, well, how do I click a mouse? Let's go to SFML. Sort of learn this. Go to learn. The tutorials might have something. Keyboard, mouse, and joysticks. And let's just do this. So if the mouse button is pressed, then we'll create a particle at that position. Here's how to get the mouse positions. And we want to get the mouse position relative to the window or our window that we've created here. Okay. So I'm going to use this here. And we'll put this in our main loop. Okay, so how to get the position, and then how to check for the mouse click. Okay, and I'm just doing this as quick as possible to keep the video a reasonable length for folks here. Okay. And here we go. Here is our position. And we don't have that function here, so we have this. And we have our mouse clicks. Okay. So what I want to do though is maybe get a little bit of feedback when I'm doing the mouse click. So maybe I can just print out a message here. Mouse clicked. Okay. So that'll just print out to the console here. Standard. Okay, so we get the position from our window, which is just, well, it's called window. Okay. So let's go ahead and run that, make sure everything's working. Oops, and I didn't include our IOStream library for doing the cout. Include IOStream. And let me go back. So this is what we are working on, our mouse clicking code. Looks good. So let's go ahead and run it. I click the mouse and it says mouse clicked. And it says it a bunch because, well, when you click one time, it prints out very fast. So that's what we get. So we can do a little bit better here, just because I want to show you a little bit of debugging here. And let's actually just print out the sort of position here. And I'm just going to abbreviate this a little bit as position. So pose.x, a comma, and then pose.y. Okay, so let's do that. Now we can actually see where we're clicking and see that it works. Okay, so I click there. If I'm sort of moving around, you can see even if I move this window around, the positions will still be relative. So the top left corner is still 0, 0, regardless if the window's here or if it's here. Okay, so that looks pretty good to me. It is printing a lot, but that's okay. Let's go ahead and create a particle now. And how do we add particles to our system? Well, we do that in world here. Okay, so let's create a particle P, and then we want to do P dot set the position. That's going to be position.x, position.y. Okay, and then we want to set the particle type. So P set the particle type. And what kind of types can we do? Well, we have particle type, and then we have, let's just do sand by default is what we're going to be working with. Then we need to add that to our world. So in our world, which is, how are we referring to it? W. We have the add particle function. So W, add particle, and P. Okay, so let's see what happens here. Maybe we'll get a segfault, maybe it won't draw, maybe something interesting will happen. Let's see. I have this, and I click here. Nothing yet here. Okay, so maybe our draw isn't working, or we're just not drawing at the position, or updating, or creating an object. Let's investigate a little bit what's going on. But otherwise, I like this. This is creating our particles. It should be iterating through them. And the other issue we have is maybe it's just not drawing the right color. Okay, so let's clear this out and have a look. Okay, so let's again try this out here. And if I look very carefully, and this will be one thing that you can do, if I click, I'll notice in the very left corner, you might need a really high resolution monitor to see this, but you'll notice 1 pixel shows up. So it looks like it's not being positioned properly. So this tells me maybe one of 2 things. Maybe in our draw function, since we're recreating this shape every time on the stack here, well, we probably need to set position here. So let's see what we have available here. So if I do shape, and what can I do with shapes here? And again, I'm just trying to show you the documentation here. So if I go to shape, under our classes, and let's look at our rectangle shape here. What kind of things can we do? Can we set the position anywhere? Yes, we can. So we want to set the position every time that we're drawing this. So set position, whatever our position is. Okay, so let's see if that helps us. Okay. Oh, it's lowercase s there. So there we go. Let's try to rerun this. And let's see, what did I do wrong here? Let me look at the documentation. Set position. Oh, and it takes a vector 2f here. So it needs to be a float. Or I can set these 1 at a time. Let me just set these 1 at a time, and if I set them as an integer, it'll actually cast them from an int to a float here. So let's just go ahead and do that without taking too many shortcuts here. So set position .x and m position .y here. Okay, I'll rerun this, and it should compile. And let's try to run this now. And now you can see where I'm drawing. I have some particles here. Now I have a lot, and I'm probably making stuff here, but this is pretty cool. I can kind of write here and create the particles. But what you're noticing though is they're not moving yet. Okay, so we still have to take care of this move part. And I don't know how far we are in hour 20. So this is the longest video of the semester, maybe, but well worth it here, and you'll have a nice starter code. Let's go ahead and just take care of moving things just a little bit here. So we've updated our grid, and now this becomes sort of the fun part where we get to move the particles here, okay? So how do we move things around? Before I do this, let me save everything, just because this is an exciting moment for us in our area. I'm going to comment this out and save it. Actually, I'll leave that in. So that's a nice debugging, so you can see where you're creating the particles. There. Let's go ahead and do a git status and add all of our CPP files and HPP files there. So you can see our status. Yep, we're adding all those there. Git commit, exciting benchmark where we can add particles. Still no movement yet, however. Okay, and let's go ahead and push those changes. Again, I probably waited a little bit too long before committing again, but it was a nice sort of benchmark for us. So I would certainly encourage you to add and commit more frequently. Okay, so how do we move our particles? Well, we're going to need this loop here because we need to loop through all of our particles. And what we'll do is we want to figure out what the position of our particle is. So we have this position again. This one I'll try to document a little bit more. Get particle position. And let's go ahead and we won't need this here. And I don't think we'll need our world here. Let's just make this the main event here. Okay, so we'll get the particle position that we have here. And then we've got our grid. This is going to be important that we are able to get sort of adjacent cells here. And we also want to get our particle type here. So particle type, I'm just going to call it type equals m, particles at I, get particle type. And we have a helper function for that. Get particle position and type. Okay, so then we can say, well, what we want to do here, and we have to be a little bit careful with doing a few things here. And one thing we can do is sort of by default every frame. So we're updating the grid structure here based off of what the particles are that we're reading in every time. But one thing that came to mind is we probably want to just start with our grid as a sort of fresh state here. So refresh grid to all zeros or error everywhere. Okay. Now this isn't going to be the most efficient way necessarily to do things. Okay. But I just want to go through and just zero everything out in our grid here. Okay, and just set everything to error, because then we're repopulating the grid here. And again, there is a more efficient way to do this, certainly. But I just want to get you something that's working first, and then we can make it more optimal. Okay, so now our grid's sort of zeroed out every time that we update. And then we say, well, however many particles we have, get their positions, and then update the grid based off of that. And that gives us sort of the cleanest snapshot of the grid that's keeping track of, is this air, sand, stone, or whatever. And then we'll move the particles on that grid based off of, again, looking through all the particles, figuring out their position, what the type is, and then based off of the type, so I'll say if type equals particle type sand, then we'll handle the movement of sand here. Okay, so how do we do that here? So what we want to do is sort of have three rules. And I'll go back to the spreadsheet here, or excuse me, the slideshow, and say, well, if we have sand, if the bottommost cell is free, then just move down. Update the position here, and then we'll also update the grid as well. Okay, And then we'll move down left and then down right. Okay. Okay. So let's go ahead and take care of that. So we'll say if and we sort of want to figure out what the bottom cell type is. Okay. And how do we figure that out? Well, we have a way to index into the grid based off of the row we're at, the width, and what we're looking at here. Okay, based off of our particle position. So we really want to look one row down. Okay, so so we do position at y plus 1. Okay, and that would give us our particle type here. Okay, for the bottom cell. Okay, and this is the particle type here. Okay, and then we're just going to repeat that for the left and the right bottom cells. So instead of going, we'll go one to the left and one to the right here. Okay, and what we can do then is sort of just do these rules one at a time here. And just see what happens here. Okay, so if bottom cell type is equal to air, then what we can do is essentially just the sand is sort of pushing down into the air, and the air is going above here. Okay, so we'll just update our grid here. So our M grid, and let me just copy this here, or I'll just write it out here. M grid at position.y, where we currently are, where our sand particle currently is, times the M width plus position.x is going to be equal to our sand. Okay, particle type sand. Okay, or whatever our type is. Let's just do type, because we are storing it here. And then we want to update our particle position. Okay, so our M particle, because we're moving it, right? Our M particle at I set position to be, well, whatever our position was previously, it's moved down one cell, and then the X position hasn't changed. In fact, for this, I'm just going to give you the sort of down. You'll get the idea here. I just want to do one properly. So update grid to reflect that sand has moved 1 unit down, and then update grid to reflect that air has moved 1 unit up. Okay, so now our grid at the position that it was at, and this was +1 here, and the current position that we were looking at times the width plus position.x is equal to, well, whatever we were comparing it to, air here. Particle type air. Okay, we've successfully updated our position of our sand here, and let's go ahead and just try this out really quick. Let's see if I made any compiler errors. Oops. Go back and compile. And let's see. Width should be M width and M height here at line 28. So some small fixes. M height. Okay, and let's see. If I click here, oh, interesting. Our particles are moving, and they're sort of collecting here. They're sort of doing interesting things. Now, why are they going diagonally here? Maybe I made a wrong computation. So let me just look at this here. Bottom cell here, we're looking at +1. And okay, if it's air, then we are setting our position. This is a silly mistake here. So you're going to have a lot of sort of interesting mistakes here. This is position X, and then this is position Y +1. Okay, let's try that out again. That was kind of fun and exciting. But let's see. Now we have this here. Okay. And this is pretty cool. So this is your falling sand starter code here. So now there could be some issues here. Now I'm going to try to crash this. Watch. Let's see if it'll crash on me. Actually, it's being pretty good about not setting particles, because it might be trying to create them at that negative position here. I'm going to really try to crash it. So you might get some segmentation faults here. There we go. Segmentation fault. Now, why did that happen? Well, my window is not 911 by 748. Okay. Let me wrap this up by doing git status, git add world, git commit. Working very primitive falling sands demo. However, lacks error and bounds checking. Okay, so let's go ahead and push that in. So that's the issue here. That's enough, I think, of a starter code to sort of get you the idea of what we've built if you've sort of followed along here. I would encourage you to, again, as you're following along with us, use the video to sort of build along so you can hear my design decisions and just my workflow here. But some of the things that will be useful are some helper functions here. So let me wrap this up here by saying, having an inbounds function, is the cell empty, setting a cell, and these are things that you can put in your world here that say, the bottom left. So you don't have to do all those sort of computations, add helper member functions, super useful, okay? So anyway, I hope this was sort of useful. I'll capture it in a screenshot and put it in here. That'll get you started with your Falling Sands project. And since this is a Thursday today, I'll see some of you in the live session otherwise. All right, talk to folks soon. Bye.